Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. What were we discussing yesterday, or what did we discuss yesterday? I think, or do you remember what were we discussing yesterday? I think we were discussing about the addition of hydrogen cyanide, how the addition of hydrogen cyanide take place, and the resulting compound is known as a cyanohydrin, I think, and cyanohydrin further treated with mineral acid converted into as a alpha hydroxy carboxylic acid, and that alpha hydroxy carboxylic acid further heated at high temperature produces alpha beta unsaturated carboxylic acid. This is one of the excellent synthetic route, because in this reaction there is a formation of new carbon-carbon bond, and therefore synthetic point of view is a very important that reaction, and that reaction we have discussed yesterday. What we are going to discuss today we are learning the chapter number 4, the reactions of unsaturated hydrocarbon and the carbonyl compound. So today, addition of alcohols. Everybody knows there are a lot of story regarding as alcohols, but I am not going to tell here. But here just remember as a alcohols, here reaction with aldehyde, because we are chemical point of view we are going to study here reaction with aldehyde acetal formation. First let us see what do you mean by the acetal formation. Let us see, suppose here is aldehyde, and aldehyde we know that the aldehydes are the compound having as a general formula R C double bond H is known as aldehyde, and aldehyde group is always present at the end of the carbon chain. So that is a specialty of that aldehyde group. Now it is also referred as a formyl group, C double bond OH, and here the aldehyde proton, which is highly what we can call it as a important one as far as a reaction point of view is concerned. Now here the aldehyde when treated with alcohols and form the hemiacetal first. Hemiacetal means what? There is a ether group on the same carbon atom, ether group as well as the alcoholic group is present, and that's what that type of the organic compound is called as a hemiacetal. Hemiacetal means the when the aldehyde is treated with alcohol in presence of catalytic amount of the acid, that first form hemiacetal, and that hemiacetal further treated with excess amount of the alcohol in anhydrous condition, it produce the acetal, that is called as a acetal. And as we know that aldehydes are more reactive than the ketone, and therefore this kind of the ethyl alcohol or maybe as a other general reaction we are going to see. So how it can form as a acetal, and where it is used, that acetal formation, this is a very important as far as carbohydrate chemistry is concerned, because it is used as a that acetal formation, it is used as a protection of the carbonyl group. This is one of the use of this acetal formation, and when the acetal compound is formed, that compound is very stable toward the basic as well as oxidation and the oxidizing and the reducing reagent, and by treating these compound with the catalytic amount of the acid, or mild acidic condition, still it is get regenerated, means whatever original compound we have taken, we can get back original compound. So that is a speciality are there, and therefore this is a use of, means to protect the carbonyl group. So that is one of the use or the application of this acetal formation, and that's why it is a study. If you go for higher study for MSc level, there is a protection and the deprotection, how they are used, because even though there is a addition of one step and the removal of or deprotection, that is 2 steps are added. And so when the chemical industries, when the 2 steps are added, they cause the chemical as well as pollute the, but in a certain, for the synthesis of drugs or the medicinal compounds, they required the protections are there, and for that purpose it is necessary. But at this level you just remember how the acetal is formed and where it is applied, it is used as a protection. Now let us look at as a general reaction over here. I am writing here, as we know that acetaldehyde having as a general formula R C double bond O H, and that will be treated, and this is a reversible reaction at an equilibrium. This ROH in presence of H plus catalytic amount of acid take place, and we are going to get here. So now let us see first, I am not going to show here is a mechanism. Now let us see first only as a general reaction. When it treated with, we are going to get here R C, then here is a O R, then OH, and H you can write over here. So this is called as a hemiacetal. This is called as a hemiacetal. First you can call it as a hemiacetal, means there is hydroxy group, there is a ether group as well as hydroxy group. They are present on the same carbon atom, means at a geminal position, vicinal position. You know that geminal means both the functional group present on the same carbon atom, that position is called as a geminal. When they are present at a adjacent carbon atom, that is called as a vicinal. So this is a hemiacetal, and when it is again further treated with excess amount of that alcohol in presence of acid, still there you are going to get here R C, here H, then OR, here OR. This is known as acetal formation. This is known as a acetal, you can call it as acetal second over there. So this is the general reaction. If you take as a example of R is equal to formaldehyde, you will get as a that type of the acetal. Now let us look at as a mechanism. Mechanism is very important, and as we know that mechanism is a language of organic chemistry. So now how it takes place, let us see here. R, then C double bond O H, I am writing over here, H over here, then here is a H plus. Catalytic amount of acid is here, and now this lone pair which is present on the oxygen atom will pick up the proton like this, and you are going to get here R C double bond O H and this hydrogen atom. Now look at this structure carefully. What do you see over here? The oxygen atom has a 3 bond, and therefore positive charge comes on it. When the positive charge comes on any more electronegative element, that species becomes highly unstable one, and now this or it can be resonate like this. So in this way you can write R C, then positive charge over here O H, right? So this type of the thing may happen over there, and now here we can add, what is that, alcohol, right? HO, then here R. I am also taking as a general reaction. R, then alcohol is going to attack over there here, and this get removed. So don't show this one, just for sake of convenience I don't want to make complication over there. So just remember, when that OH attacking over there, this remove like this, so that you are going to get R, then C, here is a O, H, there is a H, and then this positive charge get neutralized, so OH, and this one H. Now look at, still on this oxygen atom, there will be the, how many bonds are there? 1, 2, 3, and therefore I am putting positive charge over there. And once after that, what is going to happen? This proton is easily cleaved by losing that H plus. What you are going to get? Here you are going to get R, then you can write O, R, then here is a OH, and this H as it is. Now in the next step, what is going to happen? That hydroxy group get protonated, lone pair which is present on that oxygen atom, again pick up the proton like this, and you are going to get here R, then C, O, R as it is, then OH2, and this EH as it is. When OH2, now look at, again oxygen atom has a 3 bond, therefore positive charge on that oxygen atom. When positive charge on that oxygen atom, that becomes as unstable, and therefore this is going to the lone pair which is present over there, they forming double bond and pushing the water molecule. Here is a removal of water molecule like this, minus H2O take place, and you are going to get over here R, C, double bond O, then R, there is a hydrogen atom, you can write here like this, and now still there is a positive charge over there on this oxygen atom. And now next one, in the next step, what is going to happen? Again water molecule, now water molecule alcohol ROH is going to attack on this carbon atom and this positive charge, because this carbon atom more electrophilic in nature and nucleophile. This is going to attack on this carbon atom, neutralizing that positive charge, and you are going to get here R, C, then O, this R, lone pair over there, this is the H, and there again O, H you can write, and R here. Look at again on this oxygen atom, there will be a 3 bond, and therefore I am putting positive charge. In the next step, what is going to happen? It loses the proton like this, and you are going to get the product here R, then C, O, R. I am writing this hydrogen atom here for this, and O, R. So this is called as a acetal formation, right? This is the mechanism, acetal formation second, and here we have got, this is a hemiacetal, right? Hemiacetal first. So this is a mechanism of this. Understood this? This is a mechanism of the acetal formation, is very easily, because this one is a, let us see the some of the example. Once you know the mechanism, you can predict number of millions of product over here. So let us see whether you are able to predict the product or not. Let us see here, suppose you have a this one, let me see here, there is a C double bond O H, and that will be treated with 2 moles of methanol, CH3 CH2OH, ethanol. What will be the product? What will be the product over here? It's an excess amount, or you can write excess or 2 mole of ethanol. What do you get? What type of the product you are going to get? Just now we have seen as a mechanism, there will be a formation of acetal, right? So here you are going to get the formation of product like this. Here OR, and here not OR. Here is actually the given C H you can write here, then O C2H5, here is O C2H5, right? This ethanol we can write C2H5OH, or sometime it is written as a OH. ETOH means this is nothing but as a ethanol, or this species we can write like this, PH, then C, here hydrogen atom OET or OET, in this fashion also. So in a short, but it gives the clarity of this compound to save the time and the space also. So this is the reaction with aldehyde formation of the acetal formation we have seen. Now second reaction we are going to see, reaction with ketones. Second one B is a reaction with ketones. Reaction with ketones. Reaction with ketones, here is a ketone formation. Ketone formation. Here aldehyde is there, that's why it is acetal. And here is a formation of cyclic ketone. Cyclic ketone formation, you can remember. So here is a formation of cyclic ketone. So now, do you think why the cyclic ketone is here? What is the reason behind it? Why not the only as a ketone formation? Ketone formation is not occur because there is a cyclic ketone formation is occur. The reason behind it, the acetone is a less reactive than the aldehyde, and therefore such type of the often ethanol or methanol we cannot they cannot react with the ketone, and because the reactivity of the ketone is less as compared to as a aldehyde, and therefore there will be a formation of the cyclic ketone. Why cyclic? If that ketone do not react with a monohydric alcohol. Do you know that monohydric alcohol and dihydric alcohol? Monohydric means only single hydroxy groups are there. That type of the species is known as a monohydric. And dihydric means what? Dihydric alcohol means two hydroxy group, means both the hydroxy group are present in the same molecule. So that type of the compound is called as a dihydric. Remember, hydric means hydroxy groups are there. Mono means single and di means two. So let us see here the general reaction. Ketone, as we know that RC double bond O R dash. This is the structure of ketone. Everybody knows that, right? This is the structure of ketone, and this will be treated with this one. Let us see here HO, then CH2, OH in presence of H plus. This is called as a 1,2 diol. This is known as a 1,2 diol because at 1 and 2 position there is a hydroxy group. Therefore it is known as a 1,2 diol ethane. We can 1,2 diol or 1,2 diol ethane you can call it as, right? 1,2 diol ethane, right? Ethane. So this is the name of that reagent, and what the product is going to form? The product is going to form like this. O. In short, you can write this is a 5-membered ring is formed there. This is called as a cyclic ketone formation. Cyclic ketone formation. Understood the meaning of? There is a formation of the cycle, and therefore it is called as a cyclic formation. Cyclic ketone. Ketone are reacting, and that's why we are getting as a this type of the product. Now let us look at as a mechanism how it takes place. Mechanism over here. The mechanism now here R C double bond O R dash when it is treated with H plus, first catalytic amount of the H, this get protonated, and we are going to get here R C double bond O. H positive charge comes on that oxygen atom. Why? When the positive charge comes on oxygen atom, it becomes as a unstable one, very reactive one, and now here HO, then CH2 OH. Now OH is going to attack here, and there is a this type of the thing is going to happen. We will write here RC, then OH. Now here I am writing this O, then here CH2, here again CH2, and here is a OH, right? And these are as it is, as this. Now what is going to happen? Now next one, the H plus, right? These are the reversible reaction. this OH is picking a proton from here, and you are going to get here R, C, OH, positive charge over there, then this R as it is, then O. Now I think there will be a complication, so let me write properly over here so that you can see clearly. Here R, C, now I am writing OH here, and then this R, then here O, then CH2, here CH2, and now H. Now is a you can see clearly, right? After that there is a H plus, and this OH can pick up the proton like this, and you are going to get here R, C, OH2, positive charge over there, and now here is a R, and this other species remain. In short, this CH2 I am writing for mechanistic point of view OH over there, right? Now you can see clearly, and now the lone pair which is present over there is going to attack over there, and there is a elimination of water, and you are going to get here R, C. Here we can write like this, here is a plus, and now look at this oxygen atom again carries as a 3 bond 1, 2, 3, and therefore positive charge comes on that oxygen atom, and after that it will lose the proton like this, and you are going to minus H plus. After losing this, you are going to get R, C, then O, this O, this one, and R. This is a kettle formation, right? Kettle, cyclic kettle. This is cyclic kettle formation. So this is a compound house cyclic kettle, and the formation of cyclic structure find importance in sugar industry because these cyclic structure are interconvertible and give rise to the phenomenon called mutarotation. In a carbohydrate chemistry, these are the words are there. In T.Y.B.Sc you might have learned that one, mutarotation, everything is there. But here just how the formation of the kettle takes place, just now we have seen. And once you know the mechanism, you can able to predict the product, number of product you can predict over there. Now let me give some example over there. Suppose you have this one. Let us see the one example over here, C double bond O, CS3. Everybody know that the name of this compound, right? The name of this compound will be acetophenone. That will be treated with this one, OH in presence of H plus. What will be the product? And just now we have seen the mechanism. There is a formation of a cyclic kettle. So you will get here pH, then you can write O, this one, and there will be a CS3, right? This is a kettle formation. So I think with this we have completed as a reaction with aldehyde as well as reaction with ketone. Reaction with aldehyde form the acetal formation or the formation of the acetal, whereas reaction with ketone it form the formation of the cyclic ketone. How it is formed that we have seen here. So I think with this let us stop today here. Remaining we will see the next time. Have a nice day. Thank you.